Alright, so the last thing on this section is expected value. I was going to do this in class, but since we've been out, I'm going to make a video. Hopefully it's understandable. Alright, so expected value is what you would expect to get on average within a given distribution based on a given probability. So basically you would see something like this. In a question, I'll ask you, out of 100 flips of a coin, what is the probability of getting a heads? Or something close to that, right? In order to do that, you would take the expected value, which equals the probability times the outcome slash the number of trials. So I have outcome slash number of trials because of, depending on what the question is, you'll have to use, or you'll have to specify which one it is. Alright, so in this case, if we're to do expected value, right, the probability that we get a heads, I'll just say P1, right, times the number of trials, and I'll say X1, right? You'll do the probability times the number of trials, and then that's your answer, right? Later on, you'll see that you'll have different probabilities, and you'll add that to it, and you'll have a different number of trials, right? So if we're to write this whole formula out, we have P to the n power times X to the n, right? So we're doing one certain type of probability times a trial, another certain type of probability times a trial, and then so on, and we'll add it all together, and that's the expected value. And you'll see this in the last two examples that I'm going to go over. So let's start off small and do a very basic example. If Maggie throws 2 dice 180 times, how many times can she expect to throw a 6 and a 6? Alright, so remember, to throw a 6 and a 6, you only have a 1 out of 36 chance. Right? Remember that lattice diagram in the back of the board? To only throw a 6 and then throw another 6, it's a 1 out of 36 chance. So that is your probability, right? Your X, your number of trials would be 180, and that's going to be your X1. So your expected value would be 1 over 36 times 180, and all we had to do is simplify that, and we get 5. So what that means is that Maggie would, on average, and I'm abbreviate, on average, roll a 6, 6, as in 6 and a 6, 5 times out of 180 rolls. Alright, very basic example, but that right here, on average, is very important, right? She can only roll about 6 sixes out of 180. Right. The next example is again a very basic one. Izzy has a 63% free throw percentage. Right. So that's probability 1 would be 63, and I don't know what is going on. So 63. If Izzy attempts to shoot 53 free throws, how many times will he be successful? All right. So X1 would be 50. So we have the expected value is 0.63, all right, times 50 free throws, and that's going to give us 31.5. So Izzy will make about 32 free throws out of 50. Alright, so this is a dice rolling game, or a die rolling game, and it costs $10 to play. Alright, so this is something you guys will see on the exams later on. You roll a die, and if you roll a 5, so let's say a 5, then you win $20. Right? If you roll a 6, then you win $30. Otherwise, you don't roll any, or you don't win any money if you roll everything else. So if you roll a 1, 2, 3, a 4, that equals $0. Alright, so is this game worth to play? Why or why not? So let's think about this. So your expected value, alright, your expected winnings is this. If you roll a 5, right, and that's a 1 out of 6 chance, right, you get $20. If you roll a 6, which is also a 1 out of 6 chance, you win $30, right? The rest you'll win $0. So that's what, 1, 2, 3, 4 out of 6. So 4 out of 6 chances of getting a 0. All right. So in terms of money, let's redo this. If you pay $10 to play, then you actually win only $10, right? So say you roll a 6. If you pay $10 to play and you rolled a 6, you actually win only $20, right? And I'm subtracting $10 from each because that's how much it costs to pay, right? If you rolled a 1, 2, 3, or a 4, you actually lose $10. All right, so this is an adjustment because we actually pay $10 to play. So if we were to write all this out, this would be 10 plus 20 minus 40 all over 6, right? So this is going to be negative 10 over 6, which is equal to negative 1.67. So what this means is you're expected to win a negative $1.67 per roll. Alright, so right now you expect to win negative 1.67 per roll. No one wants to win negative dollars, so this game is not worth playing. Alright, so here's the thing. The most important part is this. You have to subtract the cost, the amount that you pay. Alright, so if you pay $10 to play, so you have to subtract that from the winning. So you could have won $20, but you already paid in $10, so you actually win only 10. You could have won $30, but since you already paid $10 to play, you actually win 20. If you won one of these, you don't really win any money, but because you paid $10 to play, you actually lost that $10. Alright, hopefully this makes sense. Please keep this in mind in the next question, right? Alright, so the last example is this. A game is played by rolling 2 dice, and there are some rules here. If the sum of the dice is either a 2 or a 12, then you win $2. If the sum is a 7, then you win $1. The cost of playing this game is 50 cents. So they're asking you, is this a fair game? And if you played 100 times, how much would you expect to win / lose? All right, so let's write this out. Hopefully you guys remember the lattice diagram in the back. We have a combinations of rolling 2 dice, and there are 36 different combinations, right? So in rolling a 2, right, a sum of 2, you can only get a 1 and a 1, right? 1 plus 1 equals 2. To roll a sum of 12, the only way you can do that is rolling a 6 out of 6, right? And then here, if you did that, you would win $2, right? So to get these two combinations, that's only 2 chances out of 36. All right. So let's look at the other one. To roll a sum of 7, right? We need a 1 and a 6. We need a 6 and a 1, or we can get a 2 out of 5, and then a 5 and a 2, a 3 and a 4, and then a 4 and a 3, right? If we roll one of these and we get a sum of 7, then you win $1, right? And to do this, you have a 1, 2, 3, 4, 5, 6 chances out of 36 to get a sum of 7, right? The rest, right? The rest of, let's say, the rest of the combos, you don't win any money, so actually you are losing 50 cents. Why? Because it takes 50 cents to play. Alright? And because this is 2, this is 6, that's 8, we have a 28 out of 36 chance of winning that. Alright, so here we have the probability, we have the outcome, probability, outcome, probability, outcome. We can now find the expected value, right? So the expected value is 2 of 36 times the $2 plus 6 of 36 times the $1, right? Plus 28 of 36 times 0, right? Because you're not really winning anything. So the one thing, again, I want you to keep in mind is this. We pay 50 cents to play. So we have to adjust the outcome of the expected value, right? So we have a 2 out of 36 chance of getting either a sum of 2 or a sum of 12. Since we paid 50 cents, we actually win only $1.50, right? Here, instead of winning $1, since we paid 50 cents, we only win 50 cents, right? And the last part, if we rolled something else and we get a sum of something that's not a 7, a 12, or a 2, then we actually lose 50 cents, right? So let's just simplify this. This would become 3 over 36 plus this would become 3 over 36, and then this would become minus 14 over 36. If we simplify this further, we get negative 8 out of 36, which equals negative 0.22. So, is this game worth playing? So for A, you lose 22 cents. So let me put negative 0.22 per roll on average, right? So you lose that every roll. If you were to roll this 100 times, how much would you win, right? So 100 times. You take negative 0.22 times 100 times, just like we did with those beginning two questions, the easy ones, and that equals $22, right? What that means is, on average, you would lose $22 per 100 rolls. Alright, so hopefully this makes sense. Please note down the process that I went through to find the answers, and this is something you guys will have to do in your questions, alright? So please watch this video again if you guys don't understand. Write down any questions, and we'll go over this in class, alright? Good luck studying.